In the previous lecture, we discussed the how to construct a network diagram. After the construction of network diagram, time analysis of the network is important for planning of various activities in the project. Before going to discussion of time analysis, we see these some notations using in basic scheduling computations. First one is the Tij, it is the estimated completion time of activity Ij. Let's consider activity A is start at event I and end at event J. Now Tij is the time taken for activity from starting event I to end event J. Next one is the earliest start time, that is ESIJ, is the time at the starting event I of the activity. So earliest start time is the time at starting event, that is I of the activity. And the earliest finishing time, EFIJ, is the time at the ending event J of the activity. Here ending event is the J, so time at the event J is the earliest finishing time. So time at the starting event, that is here starting event is the I, so time at the event I is the earliest starting time. These earliest starting time and earliest finishing time are used in the forward pass computations. Next we have to see the relationship between the ESIJ and the EFIJ, that is EFIJ equal to ESIJ plus TIJ, which means earliest finishing time equal to the earliest start time plus activity time. Next one is the LSIJ, it is the latest start time at starting event. LSIJ is the latest starting time at the starting event. LFIJ is the latest finishing time at the end event. So here end event is the J. These latest events times are used in the backward pass methods. So for the forward computation, we are using the earliest start time and the earliest finishing time. And backward pass computations, we are using the latest start time and the latest finishing time. The relationship between the latest starting time and the latest finishing time is the LSIJ equal to LFIJ minus TIJ, which means latest start time equal to the latest finishing time minus activity time. Next we see the forward pass computations. This method is used to determine the earliest event time. In this method, we have to begin from start node to move towards to the end nodes, which means we have to move from left to right, which means we have to move from starting event to ending events. So this method is consisting of the three steps. Step 1 is the let 0 be the starting time for the project. So here we have to start at the starting event and we are considering it is the 0. Earliest start time is the 0. Starting time is the 0. We have to consider it. Step 2 is the earliest finishing time of activity is the earliest start time plus activity time, which means earliest finishing time of activity Ij equal to the earliest start time of the activity Ij plus activity time. So third step is here we are considering the Ej equal to the maximum of Ei plus Tij. So third step is using for the merge events. For merge events, finishing time to be considered the maximum finishing time for the among all the activities. So this is the third step. So have to see the one example. Let's see the example problem to calculation of the earliest start time and the earliest event time by using the forward pass computations. Here it is given the network diagram along with the activity time for the various activities. So now I have to start with the earliest start time for the starting event, that is the event 1. In general, these earliest event times are represented in the two rectangular boxes and the earliest time is represented at the upper box. Then I have to start at the event 1. It is the 0. Next I have to calculate the finishing time for activity A and activity B at event 2 and 3. So that is for activity A, starting time is the 0 and ending time is the starting time plus activity time, that is the 0 plus 2. Next we have to see the finishing time at the activity B, that is starting time is the 0 and the activity time is the 3. Then finishing time at the activity B is the 3. So next we have to see for the activity C and D. So for the activity C, starting time is the 2, then finishing time will become the 2 plus 2, 4. So next we have to see the activity D, starting time is the 3 and finishing time is going to be 3 plus 4, that is the 7. Now question will be raised at event 4, which time we have to consider, whether I have to consider the 4 or 7. So here observe that one so event 4 is the merge event for activity C and D. So we have to consider the maximum finishing time maximum finishing time will become the among the C and D activities. For the C activity, finishing time is the 4 and the activity D finishing time is the 7. Among these two finishing time, we have to consider the maximum finishing time. So that is the maximum time is the 7. Then here we have to consider the finishing time is we have to consider the maximum time, that is the 7. So next we have to see the finishing time at the event 5 for the activity E, that is the 7 plus 2, 9. So next we have to see for the backward pass computations. So in general, backward pass computations are used for to determine the latest start time and the latest finishing time. So in the backward pass computations, we have to begin from the end node and move towards to the starting node, which means in this backward pass computations, we have to move from right hand side to left hand side. So I have to start at the ending event and move towards to the starting event. So here also we are having the 3 steps. First one is we have to start at the ending event and we are considering the earliest event equal to the latest event time. Step 2 is next we have to determine the latest start time, that is the latest finishing time minus activity time. Third step is so this is for the burst event. So the burst event have to consider the maximum start time for all the activities. So this is we have to see with one example problem. So this is the previous already we discussed and determine the earliest start time for all the activities by using the forward pass method. Now we have to determine the latest start time and the latest finishing time by using the backward pass method. In the backward pass method, we always have to start at the ending event. Here ending event is the 5. And also we are considering the earliest time equal to the latest time, which means earliest finishing time equal to latest finishing time. So here earliest finishing time is so for activity E is the 9. So we have to consider the latest finishing time also 9. So next we have to calculate the latest start time at the event for activity E at the event 4, that is the 9 minus 2, that is 7. So next we have to calculate So latest start time for the event 2 for activity C, that is the 7 minus 2, it will become the 5. Similarly, you have to calculate the latest starting time at the event 3 for the activity D, that is the 7 minus 4 will become the 3. So next we have to determine the latest starting time for at the event 1. So which is equal to the 5 minus 2 will become the 3 and 3 minus 3 is 0. Now once again a question will be raised among the 3 and 0 which one we have to consider the latest start time for the event 1. So in this one we have to consider the minimum value. So it is the 1 is the burst event. So for the burst event to determine the latest start time is the minimum time for the all the activities. Here two activities are there, that is the B and A, and the minimum time is the 0. We have to considering the latest start time for the event 1 is the 0. Thank you.